So welcome to lecture 4. Today we're going to talk about persistent data storage. So the learning objective today, by then today you should be able to create a web application that stores persistent data on the server and then is able to read that data back at a later time. So that is what we're going to do today. And recall that last time we're going to review a bit is that we learned a server-side CGI script, so this kind of CGI protocol. And it can be written in any language, right? So I use Python. The readings had C and Perl. You basically use any language you want on the server to write a script in the CGI manner. And what that does is that it dynamically generates a web page in response to user input. So now we're away from the static web pages. We actually can generate dynamic web pages with any code in any language. So today what we're going to do is we have a full agenda today. First thing I'm going to do is I'm actually going to go over some of the Piazza stuff because we had some good questions. And then I'm going to recap some of the course philosophy about teaching fundamentals. And then we'll get into the main lecture. So let's actually start with Piazza. So this has actually been great that we had a few questions and actually fellow students have answered them before I could even get to them. And they've actually been really good answers. So I definitely encourage you all to go check Piazza and answer each other's questions. And then the staff will also look as well. So somebody asked this question right here about the CGI script doesn't run. So, they put it in the right place. They put the URL here. Can someone recognize what might be going on without looking at the Piazza answer? So why isn't this is just loading the file. I mean, it's actually running, right? But it's actually printing out the content of the Python file and not running the Python file to generate the page. Yeah. Sorry.
Did they forget the shebang line at the beginning?
No, it's right here. It's right here. The line's right here. So one possibility is that the line may be written wrong, so that could be a possibility. But yeah, it's here. I guess they install Python 3.4 on Windows, but yeah, it's here. Yep.
Actually, there are two problems.
Okay.
One is this file has been accessed. It is directly opened
Okay.
from that place instead of opening it from the local host.
Uh-huh.
And the second is I think that file has been placed in the Apache folder.
I see. Oh, yeah. Oh, yeah, that's true. I didn't actually notice the second one. That's right. So I think the file actually needs to go into, I think it's www, right?
Yeah.
I think that's where it is for the thing. Maybe Apache CI works. I don't know what's inside Apache. But the bigger issue here, beyond putting it in the right place, is that the person was trying to access this by just double-clicking and opening the file in the browser. This is a really subtle distinction because this is sort of weird, and it gets. I didn't actually go into this last time, so I want to go into this now. So what happened here was it was the equivalent of. Actually, let me just try it. I'll just show you. So recall here, it looks like file : whatever C program files. What this does is this is what happens when you open a file up in your browser. So if I go, if I go to my CGI bin, so let me make sure I have the right one working first, which is this one, right? The lecture3.py. So I'm going to reload. So recall that I put my name in, all the stuff in. So if I actually just try to open this file on the browser here, can I open with? There's no open with. There's an open with. Let's choose it. It's not a good idea to choose a default program, but let's not use it. Let's use. Do you have Chrome? All right, let's just use Internet Explorer. Whatever. See what happens. Okay, so it's the same thing. So what I just did is I just opened the file with the web browser. This is Internet Explorer, but Chrome is the same thing. If you notice, the URL says C program files, blah blah blah, which means that when you just open a file, it'll just read that file. The browser just reads the file and just like pastes in the contents of the browser. The subtlety is just in the URL, is that if you actually access the file through localhost / whatever, that actually triggers and calls the web server. So this would not be an issue if this was on another computer, right? If this file, the server's on another computer, you can't just open it, right? Because it's not on your computer. But it is a little confusing because this file is on my computer, so technically I can just technically just open it up in my browser. But if you do that, you bypass the whole server mechanism. The server it's not going through the server, right? The only way to go through the server is for you to tell the computer, I want to go to I want to go to really http://localhost/ whatever, and that will activate the internal network to go through the server. And if you do that, then the Python file will be executed, assuming you put it in the right place, the CGI bin. It will actually run the Python file and run the Python code and generate a web page for you instead of just printing out the code of the page. So does that make sense? So just remember, when you're testing this on your own computer, you need to still go through localhost. It's a really subtle difference, but that's a source of bugs. And then we can update the Piazza. Yeah, I think you mentioned a really good point. I didn't actually see this before. That on Piazza, where was the Piazza post? So I'm going to close this. On Piazza, too many windows open. Yeah, so you should probably put it in www CGI bin. So let's actually update the answer right now, just for reference. So this is a good answer, and then also check that your file is in www CGI bin. Oh, okay. Did I? Yeah. So we wrote about the Windows thing. Yeah. Actually, yeah. So this is actually a. Oh, this is good. We should talk about this. This is also what is kind of annoying about installing this stuff, is that AMPS does include a Python install, but I couldn't actually get the Python in AMPS to work. So I had to still install Python separately and just use the C, just on my computer at least. I tried it a few times. I still had to install Python myself separately and then use the C/ wherever my Python was, Python.exe on Windows. On Mac and Linux, you're good because the Python's already pre-installed, so you don't need to install it separately. So you can check maybe your AMPS works, but for some reason my AMPS Python inside of AMPS and Python, I try to run it doesn't actually work. So, okay, so that was Piazza. I definitely encourage all of you to go check it and to contribute, because this is super useful. Well, it's as useful as you all make it by your contributions. The other thing on Piazza is the finding teams. So there's a finding teams thing there. Ah! Did I not even edit? It's another user interface issue. Oh, okay. Wow. All right. I just didn't need to edit this at all. The other thing is check Piazza for finding teams. So if you want to find teammates, last year a lot of people had success doing that. Say, oh, I want to make a team of two, or I'm a team of two and need a third person. Okay, so that's set. I want to go briefly over the course philosophy again, because I had some questions about kind of the specific technologies we're using. So recall that the specific objective of this course is to provide a strong foundation to principles of web application development. So the first half of the course will be mostly about concepts, and the second half you'll get to do your project and do a lot of coding and stuff. So if you actually notice, even though the lectures involve code, I try to keep the code to as minimum as possible, because I didn't really want to be teaching a specific framework or a set of technology. So if you actually read down in the intro page more, we won't read it all together. Actually, we can read this paragraph. You can take a minute to look through this paragraph. Right here. While I pull up my notes. All right, so if you actually visit the page, there's a little more info about that down below. But basically the philosophy is, we're not trying to teach you a specific set of technologies or languages because they change extremely fast. I'll give you examples of that. And then if I'll scroll down a bit. Welcome. Yeah, come on in. We're just starting. Yes, there's front. There's back there too. You'll find that in your jobs as you progress, basically every year or two, the web technologies turn over and specifics change really, really, really fast. And I'll give you examples of that. And then blah, 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 blah. There's more text down below if you want to read more details. What does this course not cover? There's a lot of stuff. Okay, so I'll give you an example. So, let's say that you wanted to learn a specific, if you came to me and said, we want to learn the most modern thing out there today, how should we make our web apps like Facebook or Google or whatever startup or company you're making? What is the set of technologies that are using? So, okay, let's take a look. So this is you can look at Wikipedia, comparison web application framework. So we'll go over some examples of application development frameworks in the very last few lectures. Basically what these are is this is what professionals use to produce their websites. They kind of abstract out a lot of the details that you'll have to be doing manually in this course because we want to teach fundamentals. So the question is, okay, let's say we're going to teach the latest framework, right? The first question is, what programming language should we teach for the framework? And which framework should we choose? So we'll go, here are the choices. We got 15 choices at least, right? What language should we choose first? Within each language, there's a bunch of frameworks. I'm not expecting you to read this, but so let's pick one. Right, this is a bunch of stuff, ASP.NET. There's not much in C, not much C++. There's there's Haskell ones. There's a bunch of Java ones. There's a bunch of Java frameworks for building web apps. So you're welcome to do any of these for your project, by the way. So we'll talk about the project later, but the project is completely freeform. If there's one you like and you've played with or you want to learn, you're free to do whatever you want on the server. Remember, the server is yours. We just want the app to work. JavaScript frameworks on the server side. Other languages, Perl, PHP. So PHP is very common for web development, as you can tell. These names are all inscrutable, and they also have dates on them, which is interesting, right? So these are the dates that these projects were started. Blah, 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 Python, there's more Python, Ruby, several Ruby ones. Some of you might have heard of Ruby on Rails, which is a really popular framework a few years ago. A lot of people were talking about others. There's comparisons of features, so these frameworks each have different trade-offs and features and ways of doing things and stuff. So the point of scrolling through all this, we keep scrolling and scrolling, is to show that it's obviously impossible to teach all of them. And it will be very limiting if we just teach one, right? Because then I'm just teaching you how to code in Ruby on Rails for this version. Whereas the principles that you're learning in this class are really underlying all of these frameworks. All of these frameworks use all the principles we're learning in this class. So once you learn these principles, you can pick up these frameworks on the job, on your internships for your project, no problem. They're just learning details of syntax and API calls. So beyond just simple frameworks, there are a lot of tools you can use. Oh, they actually updated this for 2015. I had a 2014 edition when I taught last year. So this is somebody collated together a lot of web development tools. You can look this up on GitHub, Tools of the Trade. I guess someone on the internet collated together a list of tools and open source software you could use to build web applications. And again, I'm just going to do a dizzying run through. There are literally, there are tens of thousands of things here, right? There's things for just doing every single possible thing. And you're welcome to use these in your projects as open source code, as long as you cite what you're using. There's just a ton of stuff. So the idea is that all these are specific tools that you can learn on demand as long as you understand all the concepts. There are just a ton of tools for everything. I can't even finish the whole list. This is a web hosting service called Heroku, which is a free web hosting service for that some of you might want to use for your projects. You can pay also. It's one of these things where you put your stuff on the server and runs your site. They offer a lot of add-ons and packages and stuff. Again, it's just dizzying, right? What are all these words? Some of them you might recognize, some of you don't. They're just dizzying stores of words and more words and funny looking icons and more stuff, and it goes on infinitely. So the reason I'm showing you this is that when people are first starting to learn web development, it's actually pretty scary, because you're like, someone just gave me a list of 5,000 technologies to try and use. Which one should I choose? And my main goal with this class is to show that once you learn these fundamentals that haven't changed in 15, 20 years, it really doesn't matter what you choose, because whatever you choose for your particular job, you'll be able to learn really easily, because they all use the same technologies that underlie the web. Specific example, I don't mean to pick on Ruby and on Rails in particular, but this is a fairly prominent example. So how many of you have heard of Ruby on Rails, the term? Oh, most of you have heard of Ruby on Rails. Good. So This started around 10 years ago. About 5-ish years ago, it got really popular. It became probably one of the most popular ways of building web applications. So there are all these people teaching it in schools and in like coding boot camps and on the job and everything. And that was the thing you had to learn if you wanted to work in web development. So there was this person on Hacker News, which is a common site like such as Slashdot and Reddit. And this was recently, and this person asked, this is a year ago, yeah, so you can read this here. I'll just let you read this paragraph right here. Again, I'm not picking on this in particular, but this happens all the time with different frameworks and languages. And this is actually a good quote also. The follow-up below is good as well, the first comment. Right, so the general gist of this is this person is saying how, they were so in demand 7 years ago and now they can barely find a job. And the person below said, yeah, this is basically what happens in the tech business, right? New languages and frameworks come and go. They've been there forever. It will always be that way. And now some things like such as Ember and Node.js are really in demand. It may be the case in a few years, may not. Who knows, right? So again, I'm not picking on this in particular, but this is emblematic of a lot of what happens in software. So here's another article. Don't drop everything, learn Ruby on Rails. This was super popular, blah, 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 a long time ago, but it's on the decline. And you see trends of this in websites. So they show like what languages or frameworks are rising and falling. But the idea is this will always happen as more technologies develop. But what doesn't change are the things that underlie the web and the technologies that you're learning in this class. So, if in the ideal kind of platonic world, we would teach all of these concepts, sitting outside on the grass, meditating, without ever touching a computer or a line of code, and we're just talking about all these great highfalutin concepts. But really, we have to use some language and we have to write some code for the lessons because the code is really a way to communicate. So I've chosen to do the server stuff in Python with as few lines as possible with the CGI mechanism. But I don't want you to think this is a Python class or this class is just about Python and you can't use PHP or Ruby or stuff. You're welcome to use anything you want for the project, but for the illustrative prop first, the class, we got to use something. And for the front end, we'll have to use JavaScript. That's mainly what runs in the browser. So questions about that? So something I want to cover a little bit in the first day, but I think it's better for you to have seen 3 lectures first to see kind of the flow of the class. If I said this in the first day, it doesn't really sink in. And you'll see this again and again as we repeat the themes in this class. Okay, so let us move on to the review. So last time we covered, so we did, whoa, what just happened? Okay, we got this. So let's review this read-only stateless server-side scripting. So read-only means that we are just taking user data and doing something. We're not writing anything to the server. Stateless is a similar term that just means that the server has no state. Like it doesn't store anything about our interactions with it. So that's what we've been doing so far with this thing, right? The server-side CGI script. So just as a super quick recap, the code is online on the course webpage. So a super quick recap, if we visit this homepage, this lecture 3 PY, it will try to run the code, and then it will break here because there's no my name. So we need to pass in a my name in here, and then we also need to pass in an age and an image, right? So by passing these parameters into the Python lecture3.py, we're giving these names values, and in the code itself, if you read here, this is the form. In the code itself, we print out we grab the values out and we print them to the terminal, which ends up being printed to the over the internet to your web browser. So you print out my name, my age, my image, and the my image one is interesting because it's actually the source part of the image. So it's actually going to grab an image with that name. So we do everything right, and we reload the page. We're going to load the page, press enter. It will say name, age, and then it'll use the cat picture. And again, I can change this to any other picture I have, such as dog. Oh, it's highlighted. Or I can find a picture somewhere else on the internet, because the image tag can be anything. It doesn't have to be just a picture on your hard drive. You can use a URL or a web link to link it. So I'm going to paste in this giant link and press enter, and there's that picture, right? So this is called an HTTP GET request, or so when people say a GET request, it means that the query is in this thing called a query string. So this should all be in reading. So GET is associated with this thing called a query string, which you put the name and the values in the string. So GET is query string, and the other way we learned is what's called a POST. And this has no query string. This is invisible. The data is invisible. With a POST, you can send more data. Because you can imagine this query string, you can't send a lot in it because the web URLs are limited usually to around 8,000 characters or something. It depends, but it's not infinite. But whereas a POST, you're just sending a blob of data. You can actually send a big piece of data. But it doesn't appear in your string, so it doesn't look as nice. So let's actually, let me go to the form. So recall that this is what we ended lecture with. The other way is this POST way. And we do this by creating a web page, just a standard web page, Lecture 3 form. We can go to code. Lecture 3 form, it's pretty short. Yeah, so there's a head, there's everything. And the key piece of code here is we have a form. We close the form. Everything inside here is called a form. The method is called post, so that means to use a post sort of request instead of a GET request. The action is, this is the script we want to send this data to when I hit submit. And the script is CGI bin / lecture 3, which is what I've been using all along. Then we have these inputs. This is called my name, my age, my image. We put in the text box, and when you hit submit, which is a special button, it will send via post all this data to the script, and the script will do stuff with it. So if I try that, I'm going to send almost the same thing. So name, age, and the image. So let's just copy this bird picture again. So this is the URL of the image. So it's just a string. So we're just sending 3 strings over to the other side. So if I hit submit, notice how the URL changes to lecture 3, because we're actually, when you hit submit, you're actually reloading the page and loading the lecture 3, and now we have the same data, right? But it's not in the string. So questions on that about the GET and the POST before we move on. So this is GET. This is POST. Okay, so now we are back to the present. Good. So here's the central problem that we're going to tackle in today's class. What if you want to store data on the server? So actually, let's just start brainstorming. So why would you want to ever store anything on the server? Yep, back.
If somebody had an account or something.
Okay, so what's an example?
So if you're on Reddit and you have your account that has all your favorite subreddits.
Okay, good. So if you have an account, you have your preferences, you have your name, maybe your picture. Good. Yeah, so that's a really good example. So user accounts is one example. Is that if you create an account on someone's web application or site, you might want to put your name and your username, password, picture. That has to be stored somewhere, right? So that should be stored on their server. So when you log in again with username and password, it will try to match it up and say, oh, you're a real person, or you don't have an account yet. Does that make sense? So basically everybody, I'm sure, has used sites where you needed accounts somehow. So you need to store data on the server. What actually happens? Actually, let's brainstorm. What happens if you actually store all the account stuff in your browser and not on the server? So imagine if you just stored everything in your browser and you don't store anything on the server. Yeah. The browser will get really slow. Yep. So if you can't store a ton of data in there, so that's one good reason, because the server is a lot more powerful. Yep. Right.
Also,
Yep, so other people can potentially see your data. So if someone goes to my computer, they can steal my password and stuff or whatever I've stored. There's a lot of answers. It's good.
If you log on from another device, you won't have that data.
Yeah, that's a good one. So if you log on from another device, you won't have the data. It's in your browser somewhere. Yeah, these are all good answers. Yep.
If you want to act the data to be used, you have to send it. If you want it to be used in any process that would run on the server,
Yep.
you'd have to send it to the server each time.
That's right.
So there'd be no reason to
Yeah, so that's another reason is that if everything's on your browser and you need something in the server system, you have to send all your data there. I mean, you basically have to do what I'm doing right now, right? I mean, this is a simple example, but you basically have to keep on sending all, I mean, this is data, right? This is just in my browser. It's just a string. You basically have to keep on sending the data to the server, tell it to do something. So it's nice if the server has the stuff there to do so. So there's security, there's privacy, there's storage, everything. Basically, you want most of the things on the account of the server. There's also you don't want other people to impersonate you, right? If someone goes to your computer and takes some file, then they can pretend to be you and stuff. Yep. In your web browser, you mean?
Yeah, so for example, if you store it on the browser and do an iPhone target, you both see the same data.
Am I on your computer or not on your? Oh, if you're on a separate computer, yeah, your data is private to your computer. So that's actually in a way that's more private, right? So yeah, so whatever's in your browser is just being stored on your hard drive here. So unless I go to your computer and steal it, I can't see it. Whereas that's actually a good point because on the server, everybody's data is on the server. So you hear about these data breaches like, Target or whatever. There's actually just one with an insurance company recently. So all this data from millions of users and all their credit cards and everything is stored on some server somewhere. So if somebody gains access to it or breaks in remotely or just goes and steals a hard drive, they have all your stuff. So that's, I guess, one disadvantage of storing everything on the server. But that's, for better or worse, how everything is done nowadays. But yeah, so people have thought about these decentralized protocols. So some people might have heard of things like Bitcoin. So some people have thought about protocols where everybody stores some information on their computer. So there's no centralized source for someone to attack or get. So things like distributed currency, something like BitTorrent where you're downloading files from different people. So there's not one central server that owns it. But yeah, but a traditional model here, we're just going to have everything on the server. Cool. Okay, so storing data in the server is a pretty central thing because if we don't have that, then the most apps we can make is the following, which is not bad. I mean, you can display your name and birds and stuff. It's not terrible, but we want to do a bit more with the server. So today we're going to introduce this idea of persistent data storage or persistent data stores. And notice how the title of this class lecture is called persistent data storage. So data means data, just anything. Storage means storage. So what does persistent mean in this context? Yeah.
It'll be there next time you come back to the site.
That's right. So persistent means that it will be there the next time you come to the site, even if it's a day later, a year later, and stuff. So an example of non-persistent storage is something you're just storing in memory in your program, right? Like every piece of software you're running, data is being created and it's stored in your RAM or your memory. But once you close that program, it's gone. In order to store persistently, so where would you actually store persistently on a computer? On the hard disk, right? And that's basically the only place that's persistent. So the memory, the RAM, all that is not persistent because when your computer turns off or you shut down the program, all that memory is technically gone. So the hard disk is persistent data storage, right? That's the whole point of having a hard drive. So they're either regular hard drives or now they have these flash drives that are much faster. But the idea is that once you turn off your computer, turn it back on, everything is still there. So let's actually, in the context of this application, let's try to build up a stuff with persistent data storage. So let's say I want to put my name. Well, let's just start with Alice25, cat.jpg. Okay, so let's say, for the purpose of this class, that whenever someone enters their info, we're going to generate a picture page for them, but we also want to store their information on the server so that we know who has tried to access their picture or something, right? So conceptually, Alice does this. She puts in this data, and then Bob puts in this data, blah, 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 blah. And then let's say Carol puts in data. And these can be different people too, right? They can be on different computers. Bear. Okay, so what I really want is for the server to record the fact that these 3 people have filled out this form, and I just want to like store it somewhere. So what is the simplest possible persistent data store? What is the simplest way you can imagine? If I told you, go implement this right now, what kind of thing would you do?
Right.
Yep. So
Make an array,
make an array. Okay, good. So what language I guess would you use?
JavaScript.
Okay, okay, good. JavaScript. And would you run that in your browser or in the server?
Server.
Okay, good. Good. So you want to run the server. So you can actually run JavaScript in the server. So most people, when they hear JavaScript, think of the browser, but there's this thing called Node.js that you can actually run JavaScript on your server. Good. So make a data structure somewhere. So what's an issue with just making, say, a data structure in your program? So we make an array. Good. We throw those Bob 23 whatever in an array or something, and then what has to happen?
At the end of the program, if you were to reopen the program, all of the values get reinitialized to 0.
That's right. So people see that. So if you create, so you need to have a program somewhere, right, that does something. So you need to create some data structure. But then if you just have in your program, when the program ends, it's not persistent. It's gone. And we start again. Yep.
Could you say write an array, and when the array is done, write it to a separate file?
Good.
That when you reopen it at the beginning of the program, it reads in that file to recall.
Good.
information?
That's great. So basically, using a file. Yep.
You're using Java or Python in the CGI.
Sure.
Can you just write them into a file?
Good. Write them into file. Yep. So using Python and a text file.
Yeah, and the text file, that's more easy.
Good. So we have things about files. So other thoughts? But yeah, so basically you have to create some data structure somewhere, right? You need to put something in a program, and then after you create the data structure in a program, you got to throw it in a file. Cool. Yeah, so basically that's the simplest possible way to do this, is that you actually, as you saw from the readings, you should, one thing you can do is just use your file system. So you're, what's a good, this is a, all right, so we'll do this whole same picture again. You're going to be tired of seeing this by the end of the class. So this is a server, conceptually, it's on the same computer here, but it's conceptually a server. You have a browser somewhere, and I have, what is it, name, age, image, so you have data. I send it to a Python script, let's say, or whatever script was called, lecture3.py, CGI bin. I send this data, right? Grab this data, I send it through, and then this does something and sends me back a web page, just like last time. But in addition to doing that, what we want to do is take this data, put it in an array or a dictionary or some kind of data structure, but in the end, we need to open a file called, I don't know, data.txt or something, and then we need to write this data to the file. Say f, doesn't matter what the syntax is, but the idea, and then we can do f.close to close the file. So this is a persistent data store, right? That we need to, every programming language, you should be able to access the file system with some kind of call. So you have to look up the syntax for your language. But usually it involves naming a file name with a string, opening it, and then using a write call to write to it, and then closing the file. So by doing that, you're actually making it persistent, because when Alice goes, we're going to write something like Alice to the file, and then when Bob opens it, we open the file and we write Bob to the file, and so on. So in this way, what we have is let's say we'll pretend, I don't want to write the code because we don't have to actually, the code doesn't actually be written, but let's pretend like we have code written to write to this file. So the first place is we write Alice to the file. What should we put after Alice to kind of separate it from everything else? Ideas.
Like a vertical line.
Okay, let's do a vertical line. Good. You like vertical lines. Good. And then what's the next thing we want to write it down? Age, which is 25, and the next thing is with a cat.jpg or something like that. That's sort of what we wrote, right? And then let's say that our convention is we're going to put a new line here, and then when the next person comes on, the script writes Bob 35 dog.jpg, and the next one Carol 45 bear.jpg. So this is, I'm not obviously, the program wouldn't do this by hand. It would be your code in Python, whatever, would have the right code to send to string, put the braces and all that stuff. So this is stored when you hit save. I guess I didn't save this here, but if you hit save, this is stored to the computer's hard drive. the server can turn off or turn back on, and you come back one day later, and your script will reload this file and parse it out and know that Alice and Bob and Carol have been here and do stuff with it. So that make sense? So you all have had introductory programming courses where you had to write to files, I assume, right? Like in Java or C or something, right? So if you actually don't use a file, your program just, all that data is gone when it exits. But with a file, you can keep it persistent across runs. Okay, so this is a good start. This now assumes that you're never going to have a vertical bar in your data, right? So it may be the case that names never have vertical bars, but let's say you want to store, instead of storing the name, let's say you want to store anything. Like someone writes in a comment, right? Like on Reddit. So their comment is, this vertical bar character is really cool, right? So that messes something up, right? Because now your code thinks the vertical bar is a separator, and this is a thing, this is another thing, and it's like completely off now, right? So there's mechanisms around this. So some people, what they do is they make it so that they store the data with quotes, so that the parsing code now gets more complicated, right? So when your code reads in this file, you have to see if there's a quote, and if there's a quote, go inside and read this as a whole thing and not as a vertical bar. Yes?
Would you still add the quote when you're doing the input during that method?
During the method, would I still add in? No. So the user doesn't have to type a quote, but the code.
If the user did type it.
That's right. So let's say this character is really cool. Now what happens?
Character gets left out.
Yeah, so like, it depends on how you write your code. Your code is going to crash or something weird thing's going to happen. And they're like, okay, so one way to do this is do escape character. So let's say they have a backslash quote, that's a real quote and not a quote. So we're going to do backslash quote. All right, so now our code has to say, here's the quote, we're going to go, this is a backslash, so look for a special thing, and don't make this, don't make this ending quote, there's just a quote, right? And we're good, and we're going. So this kind of works in your Squint, and then somebody comes in, and they, they're not an English writer, they paste in Chinese or Arabic, and your file just gets completely screwed up because your thing doesn't know how to parse that. All right, so the idea here, or another thing is, what if someone's writing more than one line? Right? Yay, we're gonna make a giant smiley face. Watch my real-time ASCII art. Look at that, right? That's a comment someone writes in Reddit. If that's your code, you're throwing in the file, this whole thing is screwed up because you're assuming every line in your program is one thing. So one way to deal with that is more escape characters. So one way people do is /n is a escape character. So you do /n, blah, blah. So the idea is that it gets pretty complicated, right? Like you do not want to do this by hand in your code because you will screw something up and your stuff will not work when someone's putting stuff in. So that's one problem so far with having a regular file. And this is why people don't have regular files oftentimes, even though there's no problem with it if you keep things simple. Another problem is this. Let's say, Alice? Okay, so we have 3 people. Let's say we have blah, 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 a bunch of more people, all right? Let's say that this is a really popular site. This is, getting to Twitter or Facebook level. And we have 10 million people, whatever, right? 100 million, let's go for 100 million. And then, this file has 100 million lines, each with a record. And now I want to say my program is, give me, find me the person find me all people. So let's say I want to do a query. Find me all people who have as their profile photo so that I can, display them together. This is a somewhat reasonable thing to do in some application. So what would your program have to do that? Look through everything, right? Because I have no idea. I mean, I don't know who has a cat picture, and we have to look through every 10,000 million, 100 million rows and do stuff. Yeah.
To store all of the information in a single array, I mean, is that possible to store all of them into 3 arrays and to use the index number to
Good. Good. So another scheme would be, so by array you mean just, you have to store in files, right? So it mean 3 files. One file is name, one file is whatever, one file is whatever. Would that be? So this is another idea that could be good. So let's say forget having one file, because then we have all this confusion, right? We have all this, if I have Alice like that gets confusing. So let's have 3 files. The first file is Alice, Bob, Carol. The second file is, was it 25, 35, 45, and the third file is, the exact things don't matter here. All right, so let's say I have 3 files. So now it's actually good because we don't need this thing anymore, right? We know that there's only one thing. So now Alice's name could be really awesome for all we care, right? And we're still good. We still have the line problem, right? So if someone's name actually, or comment actually has, spans multiple lines, we still have that issue. Okay, so we still have an issue, not as big. Like you mentioned, if we find that somebody's in this row, we can use the same index in the other one to grab all the data, so that works. But you still have to look through everything, right? If you have 10 million of them, you still have to look through them. But it's getting better. So nobody says you have to do one file, right? Another way you can split this up is you can have n files, right? You have one file for each person. So you can have Alice, 25. I'm probably messing up these numbers, but Carol. 3 files, 3 people, right? So I should have more, right? So basically, another idea is, hey, why don't you just create a file for each person, right? I mean, files are small. Let's just create a bunch of files. Yep.
Why don't you use some sort of standardized data format?
Standardized data format. Okay. So what's an idea?
JSON or XML?
Okay, good. So JSON or XML. Good. So why don't you use some kind of standardized data format, JSON, XML data format? Good. Who has heard of JSON or XML here? Good. This is awesome. Good. So let's just focus on JSON. XML is a little older, but it's the same kind of idea. There's some kind of structure. So let's just focus on JSON. Right. So the problem we have here, one of the problems we have here is that we don't have a data format. We're just making something up, right? We're just making up. Our data format is put this little character and put a new line in between. So if you have a data format like JSON, they'll take care of all of that for you. It'll take care of the quoting. It'll take care of all of that stuff. So that actually could work. So let's just say our thing is a big JSON. I probably don't have the syntax. You don't have to worry about JSON yet. We'll cover JSON later in this class. So the syntax might be off, but let's just go with it. Oops. So this is something like a list. First thing is actually double. It's actually very hard to write JSON by hand because the rules are really strict. Age 30. What is it? 25. What is the image? Blah, 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 blah. Okay, make this a little smaller. So for those of you who programmed in Python or JavaScript, the JSON format looks kind of like a data structure in your language, which is a nice thing about it. But y'all get the point here. Dog, bear. So this is, I don't know if it's syntax checks, but it's a piece of JSON data in this format. I would have to save it. So if you save this in a file called data.json, this is a file, right? You put it in a file, and then you don't have to worry about all the stuff. We know that the name is Alice, the age is whatever, and all this stuff is taken care of for us. So this is good for parsing it. So your code to read that file is simple, but we still have this problem, right? So we still have this problem, right? If there's 100 million things in this file, we still have to look through all of them and do stuff. Just to make this lecture more depressing, there's even more problems with using a file. And you'll see why I'm getting into this so much detail. This is assuming you have one person visiting your website, right? So if you have one user on your website, this JSON thing is decent. It's pretty good. One user on your website at a time, we're good. We're just writing the stuff. But most websites, hopefully anything that's successful, any successful website there's one server here. It has, several dozens, hundreds, thousands, however many people visiting it at once, right? I mean, any popular website is going to have hundreds or thousands of people at the same time. Now, what if Alice and Bob are visiting my website at the exact same time, or almost the exact same time, and want to write data to the database, right? So what might happen, it depends on how you're writing your code, is that let's say, okay, this is all simulated, so this is not for real. But let's say that Alice comes in. So imagine Alice and Bob are both two computers, right? There's Alice, there's Bob, and they're both trying to go visit the same file and put in their data. Okay, that's the scenario. Let's say my Python code starts running, or some code starts running. It starts writing A-L-I-C. Oh no, Bob's code starts running B-O-E, blah, 20, 30, 4, what, 25, 5. Oh no, we wrote two of these things. Another one. And then you see what happens, right? Yes? Isn't that the point of multi-threading? Good. So you can write your code. So now you will use threads or locks to write more code around your Python. So one thing you could do is lock the file or lock the access, right? So for those of you taking an operating system class, there's things called locking or multi-threading or these kinds of terms. That requires extra code, right, to do. So you have to write that code and get it right. Multi-threaded code, for those of you who've worked with, is notoriously hard to debug because you have to reason about Alice and Bob can come in any time. Some other time might run, and maybe Alice runs the whole way, and then Bob goes, and then Al, and then 25, and whatever, right? Another way is, let's just be really conservative and say that as soon as Alice opens the file, Bob's not allowed to touch the file. Because then we actually can ensure that Alice goes 25, cat.jpg. Alice closes the file. Now it's Bob's turn. Bob, 35, dog.jpg, right? So that's another way you can do it. You can, what they call, lock the whole file. So this is all ways of getting concurrency to work. That might be bad because let's say we have not just Alice and Bob, let's say we have 100 people hitting the site at the exact same time. Then one person will have to wait until the other 99 gets done with the file before it's their turn. So they're going to wait potentially for a long time. So that's bad too, right? So these are all issues that are coming up with just using regular files. So you can technically do this, right? If you write your code carefully enough, you can imagine, let's imagine, it's actually really great you asked this question. So let's imagine there are conceptually 1,000 people or whatever, 10 million, 100 million, make up your own number, 1 zillion people in this database, in this file. Let's say that this person wants to update their data, right? This person wants to change their, so this is a picture, image. This is age, name. Let's say this person wants to change their profile picture, which is completely legitimate to do, right? They're going on their website, options, change profile picture to monkey or whatever, kangaroo, squirrel. So it seems kind of weird that as soon as Alice comes in and tries to change her picture, this whole file is, you can see my artistic skills, this whole file is locked, right? Does that look like a lock? Yeah. This whole, looks like a camera. So this whole file is locked. So Alice comes in and tries to change the profile picture, the whole file is locked. Bob can't do anything anymore. But let's say Bob wants to change his profile picture also. But if you actually stare at this picture, there's no reason why Alice and Bob can't simultaneously change their profile pictures, right? Because they're not affecting each other. Bob is trying to edit this, Alice is trying to edit this. So if we lock the whole file, we're kind of, making Bob wait for no reason, right? But what if Alice and Bob, for some, well, it's a bad analogy, they both want to edit the same profile picture? Then we have to make one of them wait because we can't have them both writing text in it at the same time. Right, so the idea behind showing all this is to show that this is quite dismal, and it's actually really hard to get all this code right. There's no reason why you can't write code to do this, right? We've all seen, Turing equivalency and all this stuff. Like, you can write anything and anything, right? You can write code to do anything that any computer can do, but it just makes it really complicated. So in the end, what happens is if you do all these things and you try to solve all these problems with size, with concurrency writing at the same time, with the data formats, you end up getting what's called the database. So that's the crux of it. So when you, the name of this lecture is not called databases because I don't want to emphasize this, but when you do all this and you write all this code to handle all these cases, you end up with what's called a relational database. There's other kind of databases, but this is the one in your lecture notes. it turns out that really smart people 40, 30 years ago thought about these problems and had to solve them. And they made these pieces of software called relational databases that embedded all the stuff we're talking about. What do you do when there's a lot of things? What do you do when there's multiple people accessing? What do you do when there's one person writing and the computer crashes and blows up? And there are, like everything in this class, there are a bazillion kinds of relational databases. So if you look up RDBMS relational databases, there's a bunch of resources on this. And actually, do people kind of know the names of some kinds of databases just off the top of their heads? We could brainstorm some of that. Postgres, good. Other ones, yep. MySQL or MySQL, depending on what religious camp you're in. I still don't know how to pronounce it. People argue for days over this. Yes. Oracle, good. Yep. What is it? SQL Server or SQL Server, depending on what camp you're in. Good. So those are good examples of what's called relational databases. It turns out you all named most of the popular ones. So market share. This is blah, blah, something. 2011, Oracle, about half of these are commercial ones. These are ones people pay millions of dollars for, so they can buy the CEO yachts. So Oracle is the most popular one. IBM has a database, Microsoft, SQL Server, all these other ones. Open source ones, MySQL, Postgres, and SQLite are the three most popular open source free ones. So we cover most of them. Recently, if you kind of heard of other kinds of databases, they're called NoSQL databases or object databases. There's a lot of different kinds of databases that don't use this relational model. We're not really going to study them in this class, but you can use them for your projects. But we're going to stick with this relational model for this class. You can see all these percentages. So then there's a question of which one should we use, for this class, for this the remaining 20 minutes of the demo. Which one should we use? We could use this one if I had $10 million, right? We'd use this one if I had a few million dollars. So we're probably going to use an open source one because it's free. We're going to actually end up using SQLite. So who have heard of SQLite actually? Good, about half the people. Good. So SQLite, people haven't heard of it as much as something like Postgres or MySQL because it's not used that often in what people call production databases. But in fact, it's actually used a lot of places that you might expect. The reason why we're not using MySQL or Postgres for the demo is that it will take me a whole hour to set up the database and to configure it before we get to even writing one line of code. So the awesome thing about SQLite is that there's zero setup involved. And I'll show you why that's an advantage. It turns out if you go to the SQLite website, surprisingly, even though people don't usually think of it, database, it's actually self-proclaimed the most widely deployed database in the world. It's, they claim this, and I have good reason to believe them. And they claim that SQLite is likely used more than any other database engine combined. And the reason why is because every Android device, every iPhone, every Mac, every web browser, every iTunes, every Skype, every Dropbox, all these applications use SQLite as their database for storing data in their applications. And there are more iPhone and Android devices than there are computers in the world. There may be more than there are people in the world actually now. It's getting up there. It's getting to the several billions. So there is SQLite on all of these devices and all of these web browsers and everything. So with all that combined, there's probably easily, I don't have a good answer, but I would say easily 5 billion, maybe 10 billion. Right, so there are more SQLite databases running than there are people in the world. So as a consequence, SQLite is actually a very, very well-made piece of software because tens of billion people have tested it and they've fixed bugs on it. Okay, so SQLite is the database we're going to use for these demos. And we'll get back to here. So problem, we have this. This is a file. So we have this idea of relational databases. SQLite is what we're going to use. And then SQL or SQL, then I pronounced it, is the language you use, the programming language you use to interact with these sorts of databases. So this is not a databases class, so we won't go into databases in detail, but I'm just going to go through it enough for you to give a flavor. So the cool thing about SQLite, and the reason why I'm using it here, is that the database is actually just one file, which is interesting. So your SQLite database is just one file. So a database is just equal to one file on your computer. That has interesting implications because if I told you, let's say you installed Oracle or you paid for Oracle or Microsoft or Postgres, and I asked you, give me a backup of your database, what would you do? I'm hearing things left and right. Yeah? Where is the file? So if I ran MySQL in here, where is the file that's storing my SQL database? I actually don't know. So the answer is you don't know where the file is. It's somewhere, right? It has to be file somewhere. And what happens is not just one file. It's like what you're saying. It's actually multiple files. There are directories of files depending on how they optimize the layout. So there's a lot of files, and the format is kind of opaque. So the nice thing about SQLite is that it's just one file, and it's the file that you create. It's just like you're creating a file. So you can just grab that file and plop it anywhere. So that's a great way to back up or to move your database around. And that's exactly what these databases on Android and stuff do. Okay, so let's actually write some code. So in the interest of time, I'm just going to I have all this online later, but I'll just show you the code to create databases. So this is the code to create a database. So again, I'm going to use Python as the driver. So you import in Python. Python installations come with SQLite installed already. So that's another nice thing. You don't have to install a separate thing. If you install Python on your computer, you have SQLite. You don't have to install Oracle or SQL Server or whatever. So this is 5 lines of code or whatever lines. This is how you create a database. So we're going to import this library. We're going to make a connection, and we're going to call this database people.db. It's just the name of the database, which is also the name of the file. We can call this whatever you want. We create this thing called a cursor. So the data flows like this. We're going to connect, create a con object. We're going to make a cursor object called C. We're going to execute this string, and then we're going to do a commit on the connection object and close the database file. So this is good template code for you working with SQLite. If you work with MySQL or Postgres, it's probably similar code. You have to look at the documentation. But the key here is this. This is it's too long. Let me, well, I'll scroll or try to scroll. The key here is a string right here. So this is Python code, remember, and this is a string inside of the Python code. So what is the language that the string is in? SQL, right? So this is as far as Python's concerned, it's a string. It's just text. But the library knows that whatever the string is, we're going to interpret it as a SQL statement, and we're going to do something. So I'm just going to copy the string so you can see it. Again, exact syntax doesn't matter. You're going to have to play with it yourself. I'm going to indent so you can kind of see what's going on. Yeah. What this says is, essentially what this says is I'm going to create a table. So I have this concept of a table, a users table. The table is called users, and there's 3 elements, kind of 3 columns in the table. One's called name, one's called age, one's called image. These are the types. So if you're programming in Java or C, you remember type. Varchar just means a string, roughly. And this integer means a string. This means that this table can store, every row in this table stores 3 things. It stores a name, an image, an age, and an image. Make sense? So I'm going to run it, and it's going to create a database. So let me run this. Okay, so to run this, I'm going to, so recall here, there's no database file here yet, and I'm going to run a command prompt. Put a command prompt. And now I want to show you what happens in real time here. So pay attention to what happens down here in the files. So I'm just going to run C Python exe. I'm going to run what is called lecture 4 create database. No, lecture 4 create database. Okay, so I'm just running this command once. And if I run this, look what happens up there. Notice how this people.db just appeared, right? So that just created a DB file. Well, it's called people.db. That's appeared in my directory. If I try to run this again, what happens? It actually says that the table already exists. So it tried to actually open the file and create a table again, but it already exists, so it doesn't let you do it twice. So running it once is enough. So if I actually, just to show there's nothing weird going on, if I delete the file, this is me deleting my database. This is me deleting my database. And if I run it again, you can't see the code here, but I'm going to run it again, and you're going to see it pop up up top. And the people.db is there. Yes?
If you had data in your database and then try to run your create your database, would it erase the previous data?
No, I won't. I think the create table will just say, I already have a table, don't do anything and die. Yeah. You can test it though. Yeah.
So for this Python code, do I have to run this Python code in the CG
That's right. That's a great question. So where are you running this script, right? So you have to you have to be running it in this directory, because if you run in this directory, it will create a PeopleDB in that directory. So you can, if you run your script from another directory, the PeopleDB will be created where you created your script. And the reason why, it's a great question. The reason why is because I just said PeopleDB. So if I said C, I don't know, desktop, this is not really that, it will actually find or create the PeopleDB in C desktop. It's just a file name. I just don't have anything, so it's the current directory. Okay, so now we have a database. So the second thing we want to do in the database is we want to insert some data in there. Let me go to this one. Okay. Again, all these files will be up later. This is 3 pieces of code here. Let's go through this one line at a time. I connect to the database again. What this does is if the database already exists, it tries to connect to it. If it doesn't exist, it creates it from scratch. I execute these 3 lines. So notice how each line, again, is a line of SQL or SQL. Where is the marker? Each line is a line of SQL, and they look kind of the same. So syntax, their syntax, but basically you want to insert into the users table. What do you want to insert? You want to insert this, this, and this, right? It's a string and stuff. So if you squint hard enough, this is like me inserting 3 rows into my database. Okay, and the crucial thing here is we need to do con.commit. So commit means that we want to commit those changes to the database file so that we're completely set and done with it. Good. So if we run this, what happens is, I wonder if there's a way to visually show this. Maybe. Well, let's see how big it is first. So let's say properties. The database before I insert anything in is, I don't know if you can remember these numbers, 3072 bytes. That's how many bytes the database file takes up right now. And let's see if we can run, what was the file called? It was called Electro4 insert DB, right? Electro4 insert DB. Okay, so if I go here, this is 3072 bytes, and then I'm gonna run the thing to insert in the database. Insert DB. Okay, I'm gonna run it and that it works. And let's see what happens. I'm just gonna press enter. It's off screen. Let's press enter. Something happened. Oh, this is the wrong file. I ran the wrong file. It's called Lecture4 insert people. Okay, naming the right thing is important. Okay, I'm gonna press enter again and run it. Okay, something happened. And then let's remember 3072, and let's see if it's different. Wait, it's still the same. Okay. Let's see what happens. Interesting. Well, let's see if there's actually data in here. Because, okay, so the data is actually in here. Okay, so this is actually interesting. You don't have, again, this is irrelevant to this particular class, but it turns out I think what happened was that when they created the database, it actually just padded it, so that actually made it kind of, you know, because 3,000 bytes is pretty big for having no data, right? If you think about it. So it actually just probably padded it. So when I inserted data in, it didn't actually insert any more in the database. It didn't augment the file at all, but there is data in here. So let's actually query it now. So I verified that actually there's stuff in here. So I'm gonna do the final script here, and then we're gonna tie it to your web app in 1 second. So notice how all I'm writing now is Python. There's nothing to do with the web right now, right? This is all just playing with databases. There's nothing to do with the websites right now. So the third file is query. So you might think, okay, you put some data in the database. How do you actually get it out, right? How do you actually read it? And the way to read it, again, we're going to connect to people at the database. Then what we're going to do is we're going to do these sorts of queries. I'm going to comment out all this stuff below first, so we don't need all of them. Okay, so the only line of code that's running here is this C execute. So this is a SQL statement, a select star. So select star means select everything from the users table. This is the simplest selection statement you can write in SQL. You can look in your notes for that. What this means is I want to grab everything from the database. And this is one pattern in Python for putting stuff in the for grabbing stuff out and going through each row and printing out the whole row. The details aren't important, but you can just play with this code. So if I run this code right now, what I should do is I should see all the rows being printed out one at a time. So if I do that, I'm going to run it down below. Did I not? I did not save the file, I think. Okay, save the file and run. Okay, so I'm going to try it again. So when I run, notice how 3 things are being printed out to my screen. The first one is, it's all the data, right? And this is a Python data structure called a tuple, so you have to parse it out farther if you want to do more. Yes?
Why is there a U in front of
Good.
the-
Yeah, so there's a U. Have people familiar with Python why there's a U there? Yeah.
It's a Unicode string, not just a string.
Right, so U stands for a Unicode string, which is the default data format, I guess, in SQLite. Store strings is called Unicode format, so then you can actually put strings in non-English languages, but it's pretty much a string. So I can actually throw, in this way, I can throw Chinese characters in the database, and it'll print out right. So what else can you do with the database? I can select everything. You can basically write any kind of SQL statement you want, and it will execute. So this is ordered by name, this is ordered by age. So let's say I want to, it's funny because these things are all ordered already. So let's say I want to select everything from users where age is less than 35. So this is a specific query, right? So if you didn't have a database, it would be kind of hard to write this because you have to look through everything, find their age, and match it up. But this query just says, give me all the users that are less than 35 years old and print me out. And let's save and run this. And it just, it prints these two, right? So this person was 40 and is filtered out. So in this way, you can write any statement you want. So you can investigate more in database on your own, but what happens is that you can, imagine you had 10 million people in this database now. The databases are meant so that you can select stuff very fast. So it actually ends up not going through every single thing. So if you actually, how many of you have taken a databases course here or anywhere? Okay, so if you study the database course, you'll know about things like creating indices and other stuff to doing it fast, but we don't need to care about that purpose of this course. So in the last 5 minutes, what I want to do is actually hook up this stuff to the web application. So I've been writing in Python so far because our web application is written in Python, not for any other particular good reason. So in the last few minutes, what I want to do is augment the lecture 4, the lecture 3 form. Where's lecture 4? Lecture 4 insert DB. Okay. Yeah, lecture 3 is this form. Okay, so what I want to do is actually make it so that we insert those values in the database. So I will show you, this is exactly the code from lecture 3. I just pasted some more stuff in. Recall that when you visit this page, we grab this data from the user. Now this is the line that inserts stuff in the database. So it's a little bit long here. So we actually just import SQLite, and then we execute this code. So if you look at this code, what it does is that it inserts into users these 3 question marks. And what the question marks mean is that we're going to create a data structure and throw those 3 variables in the place of those question marks. So what this does is if I fill in my name as 32, cat.jpg, it will actually insert those values into the database and just throw them into the database wholesale. So by me visiting this page, I've actually not only displayed my web page with my cat picture or whatever, I've actually modified the database so that it inserted those things into them. It does one more thing. I will scroll down right here. The last thing it does is this, which is a little different than before. What this does is, again, this is regular Python code executing. It does my select star from users. Remember what select star from user does, right? It just goes through every row in the database and grabs everything out. Now we're in the for loop. Now we actually need to grab the name, age, and image out of the each row. So to do that in Python, you do R is the name of the row, so you do R0, R1, R2. You grab them out and you put them in name, age, and image. So the equivalent of this is if I'm running on the command line, that I want to grab this thing out, this thing out, and this thing out into variables so you can actually do stuff with them. And once I do that, I can actually play with them. I can say h2 name, h2 age, we have to convert to string as a number, and then image, image. and then close it. So what will this, let's say I have 10 people in my database already. When I visit this page, what would it kind of print out to the screen or the browser? Yeah.
It will print out the list of all the 10 people.
Good. All the 10 people, name, age, image, name, age, image, name, age, image. Okay, so in the last 3 minutes, if this all works, let's try it. Oh, we have to change Lecture 3 form. 1 second. So the Lecture 3 form is one we've been using to query it. Actually, no, we don't need to use form. Let's just do this with the get. So Lecture 4 insert DB. Okay, so let's go to our thing here. So we're going to go to localhost. Type in Lecture 4 insert DB. Okay, good. There's an error, which is good. So we say my name, whatever, and then column name not unique. Oh, I'm already in the database. Let's do Joe. Okay, good. So this database actually already has a bunch of people in it, or from before. So I've inserted Joe into my database with 10,000 and cat, and now that for loop, what it's doing, this for loop, what it's doing is that it's going through every person in my database, grabbing their name, age, and image, and plopping a piece of HTML out with that. So if you look at my database, this is actually what's in my database. So the first entry, I guess, was my own name. I put my own name in. John had this. Jane had this. These were all in the database. And then Joe has 10,000 as a cat. So if I go visit again, let's say Carol, and let's say her image is a, I don't know, is the bird. Wow, that just totally moved this thing out. Let's say Carol has the bird. Press enter. Now it will, my database has Philip, John, Jane, Joe, and then Carol has the bird, right? So now if I actually look at my database, let's see what happens. So this is persistent because if I look at my database, QueryDB, I'm going to comment all these out. I'm going to do a select star from users. So all I'm doing with this script is selecting all the people in the database right now. So what's in my database right now? Let's go look. And if you stare at it, you'll see that there's Philip, John, Jane, our new one, Joe, and Carol, and that's the data. So just to check that this works, let's insert one more person. Let's insert one more person on here with, I don't know, it's like a just really long, weird name. And then age is, blah, 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 blah. And image is, I don't know, we can put image. We'll just do a bear again. We'll just do bear for this. /bear. And once we do that, we're going to put this person in the database. We're going to run it. It loads all the people out. Put that person in. And then for the final thing, we're going to query it. This is the database, and it has that final entry with this annoying person with a terrible long name. So that's it for this time. And I will see you all next time. And think about project partners. And I'll put all this code online.